Now we study one example. Find integrating factor of 1 plus x square into dy by dx plus y is equals to e raised to tan inverse x. So this is the given differential equation. Now write the given differential equation. This is the given differential equation 1 plus x square into dy by dx plus y is equal to e raised to tan inverse x. And directly it is not in the form of linear differential equation. When we dividing throughout by 1 plus x square, that is 1 plus x square. Why we choose for dividing on both sides 1 plus x square? Because in the general form of linear differential equation, that is in this form, no one coefficient of dy by dx, no any coefficient for dy by dx, and here 1 plus x square is coefficient present. So to remove this coefficient, dividing throughout on both sides by 1 plus x square, then the equation becomes dy by dx, because 1 plus x square cancelled out, 1 divided by 1 plus x square into y is equals to e raised to tan inverse x divided by 1 plus x square. So this is now in general form of linear differential equation. When we comparing it with general form, that is this equation comparing with general form, then we will get p is equals to 1 divided by 1 plus x square, where p is coefficient of y, therefore the coefficient of y is 1 divided by 1 plus x square, therefore p is equals to 1 divided by 1 plus x square, and q means all RHS, and RHS is that e raised to tan inverse x divided by 1 plus x square, therefore this is the value of q. So in this manner, by comparing the given differential equation is with general form of linear differential equation, we will get the value of p and q. Now by using this value, find out first integrating factor, and here only asking that find the integrating factor of the given differential equation. So we have need here only finding out the integrating factor. Therefore using the formula for integrating factor, where y is dependent variables, therefore their integrating factor formula is that integrating factor equals to e raised to integration p dx. Okay, where e raised to integration p dx. So first of all we find out the value of integration p dx. Therefore integration p dx, write the value of p and find out the integration, becomes tan inverse x. Therefore e raised to integration p dx, therefore e raised to tan inverse x, and that's its integrating factor. So in this manner we can find the integrating factor of any linear differential equation. Now we will study next another one example, and example is that solve the given differential equation x into log x into dy by dx plus y is equals to 2 into log x. So write down the given differential equation, that is equation number 1, and first choose for dividing throughout on both sides. Which term? Obviously coefficient of dy by dx, that is x into log x. So dividing throughout on both sides, dividing on both sides by x into log x in equation number 1. Therefore equation 1 becomes this dy by dx, because x into log x cancel out dividing on both sides. 1 divided by x into log x is present here as the coefficient of y, and on the RHS what happens on the RHS, what is remaining, that on the RHS first what is present here on the RHS, in the RHS present here 2 into log x, and we divide by x into log x, so what cancelled? This log x and log x cancel, and what remaining? 2 divided by x remaining. So in this manner the RHS becomes 2 divided by x. After that, the given differential equation is now converted into linear differential equation. Now comparing it with general form of linear differential equation, then we will get the value of p and q, and value of p is 1 divided by x into log x, that is coefficient of y, and value of q is 2 by x, that is RHS of the linear differential equation. Now by using this value of p and q, finding out first integrating factor, and to find integrating factor, find first the value of integration p dx. So integration p dx, write down the value of p, 1 divided by x into log x into dx. Now to find this integral, we use substitution, that substitution is that log x is equals to t, and therefore 1 by x into dx becomes dt by the derivative. So by using this substitution, the given equation becomes integration p dx is equals to, the given equation becomes integration 1 by t into dt, and their integration is log t, and finally put the value of t, that is log x. Therefore integrating factor is equals to, what happens, therefore integrating factor is equals to log t, at the place of t put log x, therefore integrating factor becomes log of log x. So in this manner we will get integration p dx. So the integration p dx becomes log integration p dx becomes log of log x, log e of x, their base is e. So finally we can find the integrating factor, and integrating factor is integration e raised to integration p dx, put the value of integration p dx log base e of x, and its value becomes log x to the base e. So integrating factor becomes log x to the base e. And after finding out the integrating factor, we now solve the linear differential equation. And to solve this linear differential equation, the formula is this integrating factor equal to the formula is that y into integrating factor is equal to integration q into integrating factor dx plus c. Now put this value of integrating factor and q, therefore we will get y as it is, integrating factor log x to the base e, integration, the value of q is 2 divided by x, integrating factor log x to the base e, and plus integrating constant is c. Now find out the value, therefore we will get after finding out the value, put substitution, that is log x to the base e is equals to t, therefore 1 by x into dx is equals to dt, and therefore put this substitution in this integral, then what happens, the integrals becomes, that is y log x is equals to 2, which is constant, taking outside the taking outside the integration, this 2 taking outside the integration, and in the integration only what happens, 1 divided by x into log x to the base e into dx. Now put the substitution, that is at the place of log x t is put up, and 1 by x into dx remaining, that t is put up here for 1 by x into dx plus c as it is, and after that their integration becomes 2 into integration t square divided by 2 plus c by using x raised to n formula. Then 2 get cancelled out, and what happens, only t square remaining, and put the value of t, that is log x to the base e, therefore we get y into log x is equals to log x to the base e bracket square plus c. Here this value is value of t, and hence finally we will get the final solution of linear differential equation, and that linear differential equation solution is y into log x to the base e is equals to log x to the base e bracket square plus c. So in this manner we can finding out the solution of linear differential equation. And in brief, to solve any linear differential equation, two steps are necessary. First step is that find out the integrating factor, and second step is that find out the solution of given linear equation by using formula. And to find out the integrating factor, first we have need to convert the given differential equation in linear differential equation form. And when we convert it in linear differential equation form, then comparing with general form of linear differential equation, and when we compare it with general form of linear differential equation, we will get the value of p and q, and by using the value of p we can find out the integrating factor. And after that, by using the value of integrating factor and value of q, we can find out the final solution of linear differential equation. So in this manner we can solve any linear differential equation by using this method. So in this manner we here completely studied the solution of linear differential equations. Thank you.